If you're listening to these videos in order, then you have just seen a video that explains lines of latitude and lines of longitude. But I've got some slides that go along with that too. Lines of latitude actually are parallel with the equator, and so we have lines of latitude north of the equator and lines of latitude south of the equator, and I brought in figures to kind of emphasize that. So here we go. Here's the equator. I don't know if you can see that. We have 15 degrees north, 30 degrees north, 45 degrees north, etc. At the poles, actually, you have what we call 90 degrees latitude. Let's see, what else do we have? Longitude. Longitude I kind of think is longitude long, and here again is the Earth, and this is the North Pole, and this is the South Pole, and lines of longitude actually go kind of down from one pole to another pole. So that's a line of longitude. And lines of longitude start at what's called the prime meridian. The prime meridian is 0 longitude, and it goes through, I believe, Greenwich. And then actually on the other side, so it looks like if I were to go kind of opposite the prime meridian this way, that is what we call the international date line. So the way the prime meridian goes is you go east and you go west of the prime meridian, okay? And they meet over at the international date line at 180 degrees. Lines of longitude. So like I said, the 0 longitude goes through what's called the prime meridian, Greenwich, England. Yep. This is a kind of a map showing you the 0, the prime meridian. So kind of put in, you're probably familiar with, we've got time zones here in the United States, and the reason we have time zones is that as the Earth rotates, the sun appears to rise in the east and set in the west. Okay, the sun appears to rise in the east, set in the west as the Earth spins on its axis. So basically, the folks in our east get the sun first, and the folks in the west get the sun last. Okay, so the sun appears to go across the noon actually appears to go across the sky this way. So then what we've done, and here in the United States, and actually what we've done worldwide, is about every 15 degrees longitude or so we have a break. We have a new time zone. Now you can kind of see here on the map of the United States, we kind of have some jags, but those are our different time zones. So let's just take a look at the time zones, make sure we're all on the same page. We actually here are in the central time zone, and if you go to our east, you get to, guess what, the eastern time zone. If you go to the west of us, you have the mountain time zone, and then we have the Pacific time zone. Now notice that these are standard, and actually standard as opposed to daylight savings time, but I'm not going to worry about that. Lines of longitude, there are a few of them that are important coming up on the next slide, so I want to point some of them out. We have and they all fall at, I'll just put all these up here. Okay. We have 2 circles. We have the Arctic Circle up here, and that's at 66.5 degrees north latitude. Then we have the Antarctic Circle down here, and that's at 66.5 degrees south. Oops, looks like I missed my south there. South latitude. And then we have 2 tropics. So we have the Tropic of Cancer, that is at, guess what, the same angle that the Earth's axis of rotation is tilted. The Tropic of Cancer is 23.5 degrees north latitude, and the Tropic of Capricorn is 23.5 degrees south latitude. So you're going to want to know those, maybe for a test. And of course, 0 latitude is, dun dun dun, the equator. Now, one of the things few things to kind of helps me remember, and it might help you. I remember the Arctic Circle kind of as opposed to the Antarctic Circle. I remember Antarctic is down below. Antarctic is down below. And then kind of also related to down below, I think if we get corns on our feet, so Capricorn is actually down below. It's in the southern hemisphere. So what's important about those actually has to do with seasons. So I want to kind of run this past you. As you see here, the Earth's tilted axis of rotation, okay, Earth's tilted axis of rotation, and and I have a video, I can't remember if it's before this or after this, I think it's coming up. As the Earth orbits the sun, I told you that the rays are most direct when we're having summer in the northern hemisphere, and they're most direct in the northern hemisphere they're least direct in the northern hemisphere when we're experiencing winter. Now that directness actually goes back to those special points that I said. So the rays honestly are most direct over the Tropic of Capricorn when we are experiencing, must be Cancer, sorry, darn it. They are most direct over the Tropic of Cancer, goodness gracious, final answer, okay, about June 21st, okay. The Arctic Circle this is kind of neat. If you are above 66.5 degrees north latitude, you are going to experience, and the summer solstice, June 21st, you are going to experience 24 hours of daylight. When you are then below the Antarctic Circle, in the June 21st, you're going to have 24 hours of night. I just think that is so crazy, and it has to do with the Earth's tilted axis of rotation. It's the northern hemisphere is tilted towards the sun on that point at that time. So I kind of have here, I have an equinox. So this one is showing you the summer solstice in the northern hemisphere. This is showing you the equinox. We actually have two equinoxes, and they would both look like this. We have the autumnal equinox and the vernal equinox in the fall and the spring, respectively. And one of the things I told you about the equinox is that although I don't think that you can balance an egg to stand up straight, you do get equal amount of daylight and equal amount of nighttime during both of the equinoxes. So I have this little chart right here, and one of the things I want you to know is the basic time of the year that we get our solstices and our equinoxes. And I usually just say, here they are, good. So I usually focus on June, and I can never remember if it's the 21st through the 23rd, somewhere in there. We'll have the northern axis of rotation will be tilted most towards the sun, and the Tropic of Cancer will actually get the most intense rays, and that is what we call our summer solstice. 6 months later, we have our winter solstice. That's actually December. If you can't remember the date, tell me December 21st through the 23rd. And at that point, the subpolar point, which is actually where the rays are most intense, are over the Tropic of Capricorn. And then we have our two equinoxes. And the big thing there is we have actually equal hours of daylight and nighttime for both equinoxes. And you can hopefully know that we get our spring equinox in March, and we get our autumnal equinox in September.